Almost everyone has some innovation in them. I think they're born with innovative capability. I think very few people actually carry through to doing something with that, and I'd like to see more people realize that it's possible.
As part of the Back to the Land movement in the 1970s, Lee Danisch tucked his MIT degree under his mattress and lived many years as a simple potter in backcountry New Brunswick. Lee was eventually drawn back to the city, where his engineering skills and innovative spirit got to work in other ways, measuring underground soil movement that can predictably lead to a landslide. Like a flexible garden hose, Lee's Shape Accelerate is threaded deep into the ground and right away transmits real-time 3D images of its shape to a website. Any visual change in shape indicates a shift underground, a possible precursor to a landslide. Good to know if you live downhill a bit. Lee Danisch, recipient of the Dave Mitchell $25,000 Award of Distinction.
The problem we were trying to solve is of measuring soil movement that could lead to a landslide or a big accident at a dam or a mine or a problem at an excavation construction site. And the problem is being able to measure soil moving very slowly over a long period of time very accurately. And that's what our SAA product addresses. Just like moving a piece of wood over a tabletop, you got a stick and slip kind of effect with landslides. They are going to move just a very, very tiny bit, and just before they let go, you often get an acceleration in the movement. That's what we're trying to catch, so you can predict the slip while you're still in the sticky phase. What you look for is movement of the soil above the bedrock, and you look for an increased rate of movement. If you get that right, then you can get people out of the way or stop traffic before a landslide occurs. The SAA is like a string of sausages where each sausage knows its tilt relative to gravity. So if you add up all those tilts, you can get a set of X, Y, and Z that tells you the shape of that string of sausages. So if you imagine the array on day one having a perfectly vertical shape, on day two it might have moved a couple of millimeters over part of its length. That's what we use to tell where the soil is moving down in the ground and the rate of movement. That can help us predict landslides and cave-ins. The key element inside our array is called a MEMS sensor. That stands for Micro-Machined Electromechanical System. We use them to sense the tilt relative to gravity. That's a very accurate way to get the shape of the hose. It's as simple as that. The hose is in the ground, being moved by soil. We're able to see if it moved a millimeter per month or 5 millimeters per day, and get people out of the way if all that soil is going to break loose. When you put SAA in the ground, you get data virtually right away. In almost all of our sites, we're sending information wirelessly onto the internet, so an engineer can pick up data wherever they are, so your chances of predicting a disaster are greatly increased. I think it's safe to say that's already saved some lives. We have one that's reporting the ground around a reservoir that's being emptied, and they use that data on an hour-by-hour basis, and they're deciding whether to evacuate people or not. I'm really excited to win the Manning Award. I think that's quite an honor. I hope it gives people the ability to see this can be done and to try it for themselves, that they can start their own business and succeed.
Anything else you want to add, Lee?
I think I've said quite enough.